Good afternoon, everyone. Space exploration might sound exciting, but it comes at a high cost. Our presentation is called Space Exploration at What Cost, and I'm Maria Barbosa.
I'm Elijah Bliss.
I'm Mr. Frost.
And I'm Dylan Tellier. What if the first sign of alien life we discover is actually something we left behind?
Human exploration achievements are always highlighted. We see them on TV, in newspapers, and all over the internet. We constantly hear about new discoveries, launches, and milestones in this industry. But what we don't always hear about are the ethics behind these missions. As a space
Is it ethical to risk contamination of other planets in pursuit of human exploration in space?
Our team found that it's not ethical to risk contaminating other planets in pursuit of human exploration because it can cause health problems for astronauts, and the cost to fund these missions is extremely high. Planetary protection policies are needed to help prevent these risks.
Okay, so for our first claim, space environment can take a huge toll on human health. Being in space and or off-world affects the mental health and physical health of astronauts. It affects their mental health by creating interpersonal conflicts and stress-related issues. According to the Ethics of Escape, should humanists support space colonization? Studies of astronauts in analog missions such as NASA's High Seas and Mars 500 missions reveal that even short-duration confinement in simulated Martian environments creates psychological stress, interpersonal conflicts, and decline in mental health. The workload, isolation, and reality of being on another planet has an evident impact on astronauts and how they handle certain scenarios. Mars missions could suffer huge losses if astronauts aren't capable of staying vigilant at all times during their mission. Not only that, but being in space also affects the physical health of astronauts. Everything in space is under what is called microgravity, which is where humans and objects appear to be weightless or floating in space. Over time, microgravity decreases the bone density of astronauts. Leigh Gable, a scientist at the Human Performance Laboratory at the University of Calgary, found that 9 out of 17 astronauts do not fully recover total bone density after 12 months of recovery. Study findings suggest incomplete bone strength, density, and structure at the weight-bearing areas. Without strong gravity, human bones don't bear any weight and thus reduce the strength and density of bones. If astronauts are on a mission and they're traveling in space for extensive amounts of time, their bones begin to deteriorate in space, and once their bones are introduced to stronger gravity, they can break under the pressure.
As you can see from the graph here, the more time the astronauts spend in space, the more bone density the astronauts lose. The yellow line shown here shows the average amount of bone density that astronauts lose in space per month, which is about 1%. The highlighted region shows the range of which astronauts lose bone density per month, which ranges from 0.5 to 1.5%.
Space missions require high amount of funding. Take the Mars Return Mission, or MRS, as an example. At first, it was supposed to cost around $4 billion. That number then went up to $6 million, and according to a new report, it could exceed $8 billion. These aren't just small changes. There are billions of dollars, more than what it was planned already. Because of this, NASA has had to cut back or delay other missions to cover up the costs.
The graph over here shows the difference between how much NASA spends on their other missions compared to how much they spend on their MSR missions, which is significantly larger.
When we look at these numbers, we need to ask ourselves what we're getting in return. Spending billions of dollars doesn't equal greater revenue back to society. That makes these projects hard to justify from a financial standpoint. Also, on top of that, there's the ethical risk, the possibility of contaminating other planets with Earth organisms or vice versa, which could interfere with ecosystems and scientific research.
to the article Planetary Protection, Enabling Planetary Protection while Preventing Biological Contamination by Randy Shostak, it states that the need for planetary protection policies has increased due to the increased frequency of space missions. From this information, our team formed the solution that implementing planetary protection policies more strictly will not only protect life on other planets more efficiently, but will also ensure that scientific discoveries on other planets are accurate and credible. Because if we find life on other planets that did not originate from there, this would lead to invalid scientific findings.
There are limitations, however, such as the uncertainty about whether or not there's life after life could be constructed with our interference, and included the high cost of going on these missions, which aren't even worth it due to how impossible they are to complete successfully sterilized, and the planetary protection policies, which have become increasingly outdated and do not address all of the ethical consideration of space contamination today.
In short, astronaut health in space shows that long-duration space missions cause drastic effects to astronauts and their mental and physical health. This must be taken into account when planning future space missions to places such as Mars. The space industry is beginning to become more and more costly and has even caused companies such as NASA to cut costs in order to save missions from being shut down. Planetary protection policies highlight the importance of preventing contamination, which is to protect life on other planets and receive accurate scientific findings, all while allowing the human exploration of space. Are there any questions?